Hey guys, so sorry I'm not here today. We had a couple of deaths in my husband's family, so I am gone to a funeral today, unfortunately. But I wanted to go ahead and go on with class as normal. So I'm going to recorded a video here for you. And hopefully you've looked at our agenda at this point and you've already taken this concept check, because that's what I told the substitute to have you do first, is take the 1.3 concept check. And you had to show your work on that. So I hope that you either did the work in the show your work box or you uploaded your work with a picture on the formative so that I can give you some partial credit there. And then now we are doing this video, and I want you to run through and take notes with me, just exactly like if I were sitting there in the classroom putting these on the whiteboard. We're just going to go through the lesson. I'm going to do it exactly like I would if I were there. And then I'll answer some questions about it if you have them on Wednesday. But I don't think that this is anything that you guys haven't seen before. Today's lesson is definitely something that you should have done in Algebra 2. It's the one after this that you probably haven't done before. So, all right, so we're going to graph some linear inequalities here in just a minute, and then there is a practice worksheet. And since it's graphing inequalities, I did not put this one in formative. So I will be collecting this back up. I'm going to look at it on Wednesday. I may give you till Friday next week to go ahead and pick this up, but I am going to collect this assignment because it's not in Go Formative. So that's the only way I'll be able to check for completion on that one. Okay. All right. So let's jump over and get going on the notes here. So, okay. So this is our 1.4 notes. Okay. And you should be doing these on the 30th. Okay. All right, so this says a linear inequality is similar to a linear equation, however, with an inequality symbol instead. So this is a linear inequality right here. Y is greater than or equal to negative 2x plus 9. And I know you guys know what an inequality looks like because you should start doing them a long, long time ago. My son that is in 5th grade has already been coming home doing inequalities. You know, the alligator bites the bigger one since for a long time. So this inequality symbol, this greater than or equal to symbol should not be something that's new at all. Greater than or equal to, less than or equal to, okay? So we're going to, first of all, determine which points satisfy the inequality. So we're going to try to decide, is 7 with an X and 4 with a Y, does that make this a true statement or not? Well, we just need to plug it in and decide. Okay, oh yeah, I was going to put over here greater than or equal to, less than or equal to, right? These are our inequalities, okay? Nothing new there, so. Okay, let's check and see if X being 7 and Y being 4 makes this a true statement or not. So I'm going to plug 4 in for Y. And is that greater than or equal to negative 2 times 7, because I'm plugging 7 in for X, plus 9. And then we just do the math and we figure out, is 4 greater than or equal to, this is negative 14 plus 9. So is 4 greater than or equal to, negative 14 plus 9 is negative 5. Is that a true statement? Is 4 greater than or equal to negative 5? Yes. So this one is a yes. All right, let's do the next one. It says, is negative 1 as X and 3 as Y, does that make this a true statement? So let's plug them in. Y is 3. Greater than or equal to negative 2 times negative 1 plus 9. So is 3 greater than or equal to negative 2 times negative 1 is positive 2 plus 9. Is 3 greater than or equal to 11? No, that does not make that a true statement. Negative 1, 3 is not a true statement to satisfy this inequality. Okay, let me get a hold and move my little camera here. Okay, 10, negative 5. So we're going to try to figure out, is 10, negative 5, 10 being our X and 5 being our Y, negative 5. This is X and this is Y. And do they satisfy this inequality? Okay, so negative 5 And is that greater than or equal to negative 2 times x, which is 10, okay, plus 9. So negative 5, is that greater than or equal to negative 20? Negative 2 times positive 10 is negative 20 plus 9. So is negative 5 greater than or equal to negative 11? Is negative 5 greater than negative 11? Yes, that's true. Okay. Remember, when we have a number line, right? Zero's here, and and positive 1 is here, and negative 1 is here. Okay, and 0. And so remember, they go this way. As you go down, they go negative 1, negative 2, negative 3. So negative 11's down here, negative 5's up here, so negative 5 is bigger because the numbers get bigger as you go up the line. Okay, so that was just practicing to see if these ordered pairs fit in that inequality or not. Well, now we're going to look at graphing these things, okay? Because when we graph these, we're going to graph a line, like we know how to graph a line, y equals mx plus b. But instead of the answer just being the x's and y's just being right on that line, that are solutions to that, it can be anything above or below that line, depending on whether it's greater than or less than. All right? So when we go to graphing linear inequalities is a visual way of showing the ordered pairs that satisfy the inequality. It shows all the solutions to that inequality, shows where all the answers are that work. Like this one worked and this one worked, but this one did not. So if I were to graph this, I would shade on the side of the line where 7, 4, and 10, negative 5 were included, but not where negative 1, negative 3 was. We'll do some examples. Okay, the first thing is that we have to put the inequality in slope-intercept form. Step number 1. Be sure to flip the inequality if you multiply or divide by negative. All right, so we have to be careful here. Flip the inequality if you multiply or divide by a negative number. Super important. Don't forget, you got to flip your inequality. Then we're going to graph it. We're going to use a dashed line for just greater than or less than, and a solid line for greater than or equal to and less than or equal to. Okay, so if it's equal to, it's solid. Okay, and some teacher along the way told me to remember solid has an L in it, solid, and so this kind of looks like a line down here, like a line, like solid line, and dashed if it's not equal to. And then we just shade above the line for greater than or equal to, and below the line for less than or equal to. Okay? All right, so let's move on down here now and do some examples. All right, I'm going to leave my steps here for just a minute so I can kind of see what I'm doing. This first one says y is less than 2/3 x minus 1. And this one is already in y equals mx plus b form. Okay, remember, slope-intercept form is y equals mx plus b. So these have to be in y equals mx plus b form. Okay, and this one is y equals mx plus b. And remember the important stuff here, that this guy's slope and this guy's y-intercept. Okay, this is where we begin and this is how we move. All right, so we're going to go ahead and graph it just like we would if it were a line. All right, we're going to begin here at -1. That's our b. So we're going to go to -1. And then my slope, remember, this is how I move. My slope, rise over run, is up 2 over 3. So I'm going to go up 2, right 3. Up 2, right 3. I can also go down 2 and left 3. Down 2 and left 3. Okay, so I'm going to do this. And so since this is a less than, I'm going to have to decide whether you want a solid line or a dashed line. So for this one, since it's not an equal to, since it's just a regular less than, I'm going to do a dashed line. Okay, so I do a dashed line, just means I don't make it solid. I make it dashed up through here. And then since it's a less than, then I'm going to shade down here below. And I like to shade with a highlighter because I think it's easier to see. So all of these X's and Y's that are included down here, okay, these are all solutions that will work when I go to plug them in to this inequality. Just like up at the top, how we picked some X's and Y's and we plugged them in. Well, any number that's down here that I plug in should work and fit into this inequality. Okay, you can do a test point if you want to, just to make sure you're right, but you don't have to. But like 0, 0, this is always a really easy test point. If I plug 0 in here, if I test, sorry, didn't realize I still had my highlighter. If I test 0, 0, this is going to say 0 is less than 0 minus 1. 0 is less than negative 1, and that is not true. That means you should not be shaded where 0, 0 is, and we are not. We are shaded on the other side, so that's great. We did this right. Okay, let's do another one. This one says y is greater than or equal to negative 4x. So this one's already in slope-intercept form. We just don't have anything written back here for our b, but that's okay. That just means that b is 0. So we're going to start right at 0, 0. And my slope is negative 4, okay? So that means I'm going to go down 4, right 1, down 4, right 1. Or I can go up 4, left 1, up 4, left 1, okay? And this is an equal to, which means I'm going to have a solid line. Okay, solid line. All right, so I'll put solid over here, solid line. Okay, and so since it's a greater than, then we're going to shade above the line, okay, which above the line is on this other side over here like this. And again, if you're kind of looking at it and you go, well, it's kind of hard to tell where what above and below would be. So just pick a test point, okay? So here, I can't test 0, 0, right? Because 0, 0 is on the line. But I can test 1, 1. 1, 1 is right here. I'm saying that 1, 1 should work if I've shaded on the right side. So if I go back here and I go to test 1, 1, it should work, okay? So that means it'll say 1 is greater than or equal to negative 4 times 1. 1 is greater than or equal to negative 4. Yes, okay? So we have shaded on the right side because 1, 1 is definitely shaded there. Okay, I should have wrote up here this was dashed. Okay. All right, let's go do a couple more. I'll pull this up here. Okay, 5x plus 3y is less than or equal to 12. Okay, so this one is not in y equals mx plus b form. I have to get it in y equals mx plus b form. My lights just turned off because there's not enough movement happening in my room. So I'm going to, first thing I'm going to do is subtract the 5x, okay, right? Because we need to get it in y equals mx plus b form. So minus 5x from both sides. 3y is less than or equal to negative 5x plus 12. Okay, and then we divide everything by 3. And we get y is less than or equal to negative 5 over 3x plus 4. Okay, now our notes up at the top said to be sure and flip the inequality if we multiply or divide by a negative number. But here, I did not do that. I subtracted this guy, but that doesn't flip the sign. It's right here when you multiply or divide, if this is a negative number, then it flips the sign. It was not. Our 3 is positive, so we do not need to flip the sign. All right, let's go graph this guy. Here's our b, here's our 4, so I go up 4. And then my slope is negative 5 over 3. So I'm going to go down 5 over 3. Down 5 over 3. All right, and I can go up 5 and back 3. Okay, this is a solid line because it's an equal to. So I'm going to go solid line. All right, and then since it's a less than or equal to, then I'm going to shade below. So I'm going to go down here and shade everything because it's a less than. And if you want to do a test point and see, make sure you shade it on the right side, 0, 0 would be a really easy one to do here because 0, 0 is right there. So I can test 0, 0. So I'm going to go back to my original equation. 5 times 0 in for x plus 3 times 0 in for y, is that less than or equal to 12? Well, this is 0 plus 0, so 0 is supposed to be 12, and I did 0. Let me make that be a 12, excuse me. This is supposed to be a 12. 0 less than or equal to 12? Yes, it is. So that means we needed to have shaded where 0, 0 is included, and we did, so it's included. All right, let's do the next one. It says x minus 6y is less than negative 12. So the first thing I'm going to do is subtract the x. So negative 6y is less than negative x minus 12. Now I've got to divide by negative 6. And when we divide by a negative, that's when we have to remember to flip the sign, okay? Because I'm dividing by a negative number, divided by negative 6, all right? So it becomes y is greater than or equal to, 2 negatives make positive 1/6 x. 2 negatives make positive 12 divided by 6 is 2. So I had to flip that sign. Oh, I don't need to magically make it an equal to because it's not. But it certainly went from a less than to a greater than. Okay? Goes from a less than to a greater than. All right, let's graph this one. I go to positive 2. And then my slope is up 1 over 6. 1 over 6. Down 1, back 6. And this is a dashed line because it is not equal to. Okay. All right. And then it turned from a less than to a greater than. Now that it's a greater than, I shade above. Okay. I shade above. So you can't make that determination on where you shade until after you've got it into y equals mx plus b form. That's when you decide where you shade, if you shade above or below, okay? So you can test 0, 0 if you want. 0, 0 is right here. So it is not included in my shading. So if I plug 0, 0 in here, it shouldn't work, okay? I can test it real quick. If I test 0, 0, and I'm going to test it in the original one and show you. It'll say 0 minus 6 times 0 is less than negative 12. This is going to say 0 less than negative 12. Nope, 0 is not less than negative 12. Negative 12 is less than 0. So 0, 0 is not included in my shading. That's perfect. I did not include 0, 0 in my shading. I shaded above that, not below it. Okay. All right, let's do 2 more. We're going to do these last 2 together. All right, let's get this one in y equals mx plus b form. It is not right now, and it sure needs to be. So I'm going to subtract the 9x. So 12y is greater than or equal to negative 9x minus 60. Now I'm going to divide everything by 12 to get the y all by itself because I'm getting into y equals mx plus b form. Okay, so this now says y is greater than or equal to, and this is going to be negative. These both divide by 3. I'm not going to leave 9/12 because they both divide by 3. So this is 3/4. And then negative 60 divided by 12 is negative 5. Okay, so now I'm ready to graph. So I'm going to go to negative 5. 1, 2, 3, 4, 5. And I'm going to go either down 3 and right 4, or up 3 and left 4. Up 3 and left 4. And this one is a solid line. and it's solid just like this. I did not flip my sign because I did not divide by a negative number. 12 is not negative, so it's greater than or equal to. Greater than means I shade above. So I'm going to go up here above my line, and that is where my shading goes. Now, if I want to test a point, I can test 0, 0. It's not on the line. It's right there. When I test 0, 0, it should work. It should be a yes because 0, 0 is included in my shading. So if I test 0, 0, it's going to say 0, 9 times 0 plus 12 times 0 is greater than or equal to negative 60. This is 0 plus 0, 0 greater than or equal to negative 60, and yes, it is. Cool. So I know I did that one right because 0, 0 is included, and yep, I shaded on the side where 0, 0 is included. All right, let's do one more. X is less than negative 4. Well, I'm certainly not in y equals mx plus b form. I don't even have a y. Okay, well, let's think about this. Where does x equal negative 4? X equals negative 4, 1, 2, 3, right here. Okay, so when you have this kind of situation where you have x is less than a number, when you have x like this is a vertical line. Okay, and it's the vertical line where x equals negative 4, which is right there. 1, 2, 3, excuse me. I did negative 3. Let me fix it real quick. My old eyes, guys. Okay, negative 1, 2, 3, 4. Let's do a dashed line. Why am I doing a dashed line? I'm doing a dashed line because it is not equal to. Okay, so this one's dashed. And then where are all the numbers that are less than negative 4? Well, all the numbers that are less than negative 4 are back here on this side. So my answer is all of these numbers that are back here less than negative 4. Okay, so remember, if this one said y is greater than 7, just like this, no x included, this would graph a horizontal line up here at y is greater than 7, and then the answers would be everything greater than that. Okay, so remember, if it says x equals, it's a vertical line. If it says y equals, it's a horizontal line. All right, so now that you're done with this, you can go pick up your practice worksheet from the substitute and get started on your practice. And again, it is not in GoFormative. It's just a hard copy because I want to see your graphs. Have a great day, you guys. I'll see you Wednesday.